Hello, welcome to another Anatomy and Physiology II Bio 265 video in a nutshell. Today we're going to be talking about the platelet plug, and it's important to realize that the platelet plug is part of a three-step process that is going to begin with vascular spasm, and then platelet plug is going to be step number 2, and then finally, and we won't talk about it in this video, but then you have the clotting cascade. So when you realize that it's part of a process, these all kind of lead to each other or build on each other. So vascular spasm will come first, and it's going to close down those blood vessels. It's going to decrease the amount of blood that's lost, and it's also going to provide potential or an opportunity for the platelet plug to jump in and the proteins to bind and everything else that we're going to talk about. And then clotting cascade is going to happen as well. But let's just focus here on the first part. So platelet plug, let's say that right here is our area of injury. So up here, we have our bloodstream coming by, and typically you would have endothelial cells that are lining the bloodstream, and they protect what's underneath so it doesn't get exposed. And you have underneath here, you have collagen fibers that provide structural strength, and when you have a cut, they're now exposed to the blood, and you have these little collagen fibers that if you will, the proteins in the blood can now see where they previously couldn't. They're now exposed. And there is a protein called VWF, or von Willebrand factor. Pronounce that 10 times fast. Von Willebrand factor, it is going to come, this protein, and it's going to hook onto or bind to these exposed collagen fibers. And once it's hooked on, then you can have your platelets. And platelets they were originally part of a megakaryocyte that blew up and made all these little, they're not really even cells. They're little structures that float around, and their job is to stop bleeding. And let's say that our platelets look something like this. So our platelets are going to come on down, and when they run into some von Willebrand factor that's hooked onto collagen, then these platelets are going to undergo what we call activation. So this process of activation is a three-part process where first they're going to change their shape, and then second they are going to I'm just going to say fibrinogen receptors. They're going to express fibrinogen receptors, and the third thing that they're going to do is they will release granules. So the first one of those, the shape change, they are going to start, it looks like they grow tentacles almost like an octopus. And those tentacles and that shape change is going to allow them to start kind of reaching out to other platelets. And we'll explain why that's important in a minute. But as they change their shape, they then start to express receptors for fibrinogen. So fibrinogen is another protein that is in the blood, and let's do that one in yellow. So here's our fibrinogen, green, oops, no, green will work. So our fibrinogen, it's a protein that's just chilling over here, but when our platelets have receptors for it, then it can come down and it can hook onto a fibrinogen receptor on platelet A, and it can hook onto a fibrinogen receptor on platelet B. And so I'll have to draw a few of these in so they're a little bit longer. But what happens is that these receptors are hooking the platelets to each other. And so pretty soon you have all of these different platelets that are hooking on and binding to each other via fibrinogen. And that process allows them to start forming kind of a net across the wound as they all hook together. And the third thing that's going to happen is they're going to release granules. And those granules come in, I guess, two flavors, if you want to call it that. You have alpha and you have densa. And the alpha granules, they are more about kind of a long-term wound healing. They include stuff like more VWF and also something called PDGF, or platelet-derived growth factor. And that platelet-derived growth factor, let's draw it actually. So if our platelet-derived growth factor is here in black, so it was inside as a granule, but then they released their packets of granules out into their environment, And those granules can then travel to this damaged tissue right here, and it can move into the damaged tissue, that platelet-derived growth factor, and it will stimulate these cells here around the edge that have been damaged or hurt to start dividing, multiplying, fixing the cut or the wound. And so again, long-term wound healing. Now back to our densa granules. The densa granules, they're all about activating other platelets. And so they have things in them like, for example, thromboxane and ADP, and there's several others. But these chemicals here that are released, they have the potential to come up and over to these other platelets. And when thromboxane or ADP bind onto these other platelets that are floating around over here, then they are going to be activated. So now this platelet here is going to change shape. It's going to express fibrinogen receptors, so it can bind to other platelets, and it's going to release its own granules. So if I were to draw this all out, every single one of these platelets would be releasing granules that would be helping in healing and pulling other platelets in and activating them. And so as they all hook together, they make this big net across the cut. And nets don't do a great job of stopping fluid, so we clearly need something else here. And so all of the other blood products, red blood cells, white blood cells, whatever might be there, it's going to come and it's going to start stacking on top of this platelet net. And after everything piles on, my term for it's a cellular doggy pile, but pretty soon all of the holes have been covered or blocked up. And then the platelets, they undergo what's called aggregation, meaning that inside of these platelets, there are basically little muscles. It's actin and myosin, just like in a muscle, and that those fibers, they pull the arms of the platelet, if you will, in. So I don't really know how to draw that in the way that I would like, but can you imagine these platelets pulling in and these platelets pulling in, and the net result is all the sides of the wound get pulled more towards the center. And as all of those edges gets pulled in, well, the size of the cut has gotten smaller and it's going to be easier to heal now. And then this is the point where the clotting cascade would jump in, and we'll talk about that in another video. But these are the basics for the platelet plug. And remember that it was the vascular spasm that came first that kind of set this all up so that the platelets could jump in and do their job. So good luck with your studies, and thanks for letting me share with you.